All right, guys, we are continuing proofs with justifying statements. So you guys will be able to fill in a 2-column proof using geometric and algebraic reasoning. So we just did algebraic. Now we're going to move on to a little bit more in depth with geometry. We're going to correctly decide which definition, postulate, theorem, property, any of those allows you to make a conclusion from a given, and then complete a basic 2-column geometric proof. So if you have not already, get out your handy dandy reference sheet. So you will be using both sides of that to help you answer these questions here. So the angle ABC is congruent to angle ABC. That is the reflexive property. If something equals itself, it's a reflexive property. For number 2, we have angle B is congruent to angle C, and angle C is congruent to angle B. That is the symmetric property. We can flip those around, and it is still saying the same exact thing. For number 3, line segment DE is congruent to line segment EF, and line segment EF is congruent to line segment LM, which means that if we were to, cross these two out here, line segment DE is congruent to LM, which means the transitive property. AB equals 2 and AB plus BC equals 7. So then we have 2 plus BC equals 7. So we are plugging that in, which is the substitution property. Whenever you plug something in, it's a substitution property. Number 5, U equals Z and Z equals 4, so U equals 4. Now you can have two answers here. You can either have transitive property, you are, flipping it, so you're crossing off those Z's there, or you have substitution, you are taking out, you are plugging 4 in for Z. Number 6, measure of angle Z is equal to measure of angle X, and measure of angle X is equal to measure of angle Z, which would be symmetric property. Number 7, LM equals 9 plus 10, LM equals 19. Because you are combining like terms, CLT, combining like terms, that is simplify. Number 8, 4x plus 2y equals 10, and x equals y plus 5. So then our next one is 4 times y plus 5. I'm taking this and plugging it in for what x is, which would be the substitution property. For number 9, AB equals 8, and 5 plus AB equals 13. So I'm adding 5 to AB, so I also have to add 5 to 8, and that is the addition property. Number 10, 4x equals 40, and then x equals 10. Obviously, we're dividing both sides by 4, so that is the division property. Okay, now here is where your handy-dandy reference sheet comes in. Now we're working with geometry stuff, not algebra. So the given is angle 1 and angle 2 are complementary. The conclusion would be the measure of angle 1 and angle 2 equals 90. So look at number 7 on your reference sheet. Excuse me. Both those sentences work and would be true about this. Actually, the second sentence is better. So this would be the definition of complementary. Angle 1 and angle 2 form a linear pair. The conclusion is angle 1 and angle 2 are supplementary. So the justification there would be number 4 on your handy-dandy reference sheet, the linear pair postulate. Because any angles that form a linear pair means they are supplementary. Number 3, angle 1 and angle 2 are supplementary. So measure of angle 1 plus measure of angle 2 equals 180. That's similar to number 1 that we just did. So look at number 8 on your reference sheet, and that would be the definition of supplementary. Number 4, given the measure of angle 1 plus the measure of angle 2 equals 180, angle 1 and angle 2 are supplementary. So we're just flip-flopping that. It's saying the same exact thing, just in a different order. It's still the definition of supplementary. Number 5, given AB equals BC, the conclusion would be line segment AB is congruent to line segment BC. If you look at number 1, it's talking about line segments and their lengths, and then it's also talking about angles and their measures in number 2, and that is the definition of congruence. Number 6, angle A and angle B are vertical angles, so that means angle A is congruent to angle B. If you remember from chapter 1, that's the vertical angles theorem. Number 7, given angle A is congruent to angle B, the conclusion would be measure of angle A equals the measure of angle B, which again is the definition of congruence. Number 8, given the following diagram, the conclusion would be x plus 10 equals AC, a piece and a piece equals a whole. This is the segment addition postulate. Again, we did that in chapter 1. Number 9, P is the midpoint of line segment AB. The conclusion is line segment AP is congruent to line segment PB. And that is justified by the definition of a midpoint, which is number, where is that at? That's number 3 on your handy dandy reasons reference sheet. So go ahead and flip to the back. So we are doing basic proofs here, okay? So given is always your reason 1. Always, always. You are never going to write prove as your reason. Your statement that is your last statement is always going to be what the proof says is prove. So you want to work in small steps. You don't want to take 2 and 3 steps at once. You want to take 1 step at a time. So for the first one, given angle 1 and angle 2 are supplementary, prove that measure of angle 1 plus the measure of angle 2 equals 180. So the given is angle 1 and angle 2 are supplementary. Then if we look on our reference sheet, the definition of supplementary tells me that if they are actually supplementary, then the measures are equal to 180. So the reason for that is the definition of supplementary. The next one, angle 4 is a right angle. Prove that measure of angle 4 equals 90. Okay, the given is the angle is a right angle. So then look on our sheet. We can go down to number 16 there. If the measure of an angle equals 90 degrees, then the angle is a right angle. So that would be definition of a right angle. You can do it in either order there. It can be, you know, you're taking the conditional and then you're making it the converse. Both of them are still true. Angle 1 and angle 2 are complementary. Prove that the measure of angle 1 plus the measure of angle 2 equals 90. So look at number 7 here. That would be the definition of complementary that makes that true. Given angle 1 and angle 2 form a linear pair. So we are going to write that in our number 1 statement, okay, because it's not written there for us, and that is the given. Angle 1 and angle 2. We know if they're a linear pair, then they are supplementary, and we know that because of the linear pair postulate. Okay, and if 2 angles are supplementary, we can go back to 8 and use the definition of supplementary to get that the measure of angle 1 plus the measure of angle 2 is 180 because of the definition of supplementary. The last one then, so we want to write our given down in the statement. So AC equals 30 and BC equals 10. Prove that AB equals 20. So my second statement says AB plus BC equals AC. AB, I didn't want to write that. AB, so we're taking this piece here and adding it to this piece, and it equals the whole thing. So that is the segment addition postulate. We can take a piece plus a piece and equal it to the whole. Then, because they give me an AC and a BC, I can plug in those numbers. And I get AB plus 10, which is the BC, equals AC, which is 30, and that is the substitution property. Then all I need to do is solve for what AB is. So I need to subtract 10 from both sides and that is the subtraction property to get AB equals 20. Please take a picture of this completed notes and put it onto Canvas. You have obviously 3 things to upload today. So you have the notes from 2.5, you have the homework from 2.5, and then you also have this 2.5 continued. So please make sure that you are uploading everything. If you have any questions, as always, shoot me an email. I will respond when I can, and have a great weekend, guys.